Hi everyone, welcome to that channel and the AI meetup. It's the Artificial Intelligence and Cloud Toronto meetup group. Really great to have you here. We have a really great show for you. My name is Denise. I'm an executive producer here at That Channel Studios. I'm very excited to introduce our very first speaker. And his name is Shailendra Pathak. And he is a machine learner and he uses PySpark. So very nice to have him here. And big shout out also to Hiran and Chandran. And yes, so welcome to the meetup. And I'd like to now introduce Shailendra Pathak. Thank you.
Hello all. So here I am, Shailendra. Just to give some background, I have been doing analytics for like 15 years now across different countries, geographies, domains. Started with the financial sector, did a lot of credit risk and market capitalization and things like that, regulatory analysis as well. Then moved on to telecom, did like 5 years in telecom sector for analytics and like 4G, switch over 5G and things like that. Now also doing retail as well as some kind of brick and mortar thing as well. And over a period of this long career, I would say, I've seen it transition to multiple levels. We started with something called SPSS, modular and things like that, IBM and small software like lightweight software, which moved on to later on to SaaS, and which was quite good, which is still industry stalwart as far as credit risk modeling is still considered. And then the open age came, and now we have so many software. It started with R, which was very, very academic and econometric, I would say. By the way, by degree, by education, I'm an econometrician, so it's not that I don't like econometrics, I love it. But the thing is, over time, as computing power as well as the data storage increased, now we have moved on to machine learning. So that's a precursor to everything, because you cannot have machine learning if you have 10,000 rows of data. That's bullshit. Okay, you need tons of data so that you can enable machine learning, right? So today we are talking about Python and PySpark and Spark on the whole, right? These are all just tools, they are just tools for you to be used when you feel they are good enough or they are relevant enough, right? If you have 100 rows of data, it doesn't make sense, right? So very important thing to understand is that you need to have the use case for everything before you jump in it, right? So now let's talk about Spark, given that we have some context. For data scientists, and again, let me just set a few things right here. We are talking about Spark application for data science. We are not talking about Spark in general, because it's a huge platform. You can literally make anything, as long as it has data in it, right? So we are talking about data science, right? As some of you would know, Spark, you can basically code in Java and in using R also, Python, Scala. So, but if you are a data engineer where your job is mostly just to leverage the data and move it from here and there and create stuff, you are mostly doing data engineering stuff, then you would most likely use Scala, because it's far more wide in terms of its application. But when it comes to data science, when it comes to insight generation, you really start somewhere, and that somewhere is you have some data and you do a lot of data manipulation, data mining, data, you move a lot, you create new things, and then you apply machine learning stuff. Obviously, you cannot run a neural network model in Java. It's not going to make sense, because you are not going to design that program or algorithm by itself, right? So what we are going to do in today's class, we are going to touch base on what PySpark looks like. So Spark, the moment you touch Python API to code in Spark, it's called PySpark, right? If you use Scala, you can do the same, right? You can code in Scala and it will still be on the Spark platform. Some people use R also, it's pretty limited. Of course, you can code in Java. You can use SQL within Spark, which is very, very handy, because like most of us, if you work in the data field, you kind of do and know SQL, right? So let's start. So since we don't have much time, so I'll just quickly give you a glance of what, why do we need Spark? That's the first thing that you should be asking, because there are so many software available and so many different things available. So some of the, it's slightly smaller and the contrast is crazy. But anyways, the most important thing is you would have heard about Hadoop and MapReduce and everything, and it was a wave, but now very few people talk about working in Hadoop, right? People want to move up. Why is it so? Because if you look at Spark, the way it is designed, very, very loosely speaking, you have an HDFS layer, which is nothing but the file management system, which you can use commodity hardware and you can write tons of data by using like cheap stuff, cheap hardware, and you can scale it up. To control that environment, you need something for resource management. That's what is Yarn, and together it is called Hadoop Yarn. The problem with Hadoop is that everything is a read and write cycle. So for every aspect, you have to tell Hadoop that start from here and end there. There's nothing in between. This is solved by the Spark environment, right? In Spark, you have above the Hadoop cluster, you have a high-end server as well. So what it does now, the first instance is, let's say, a read instance where you are just loading up the data from the Hadoop clusters and so on and so forth. But then after that, whatever you do, you kind of hold it in memory, right? That's why Spark is always called as in-memory processing, right? It leads to overflow if it can't process it, right? But then it's stable because it goes back to Hadoop. So it will not crash, it will still do its job, maybe slightly slower. This combination of a high-end server which enables in-memory processing as well as the original Hadoop environment enables you to work 100 times, up to 100 times faster than a conventional Hadoop setup, right? And also, the beautiful thing about Spark is, which started as a Scala platform, everything is written in Scala in Spark, but then it allows you to use these APIs. So you can use Spark SQL, which is nothing but SQL. You can use Spark streaming for handling streaming data. Machine learning, you can use MLab library for GraphX, which will allow you to create tons of graphs, beautiful graphs. Spark R, which is nothing but when you want to code it in R. And then you have DataFrames, which is the beautiful thing, which is the latest thing, and it is the thing for data scientists. Why? So anybody understands what is a data frame before I just jump on it? Can anybody explain to me what is a data frame? I don't want to make it a one-way traffic, Anybody, just try. It's okay to be wrong. Yeah, please. Come again? Exactly. So data frame is a relational data. That's it. Basically, when you have a variable, which you can say a column, and when you have the entries, which are the rows of data. Right? So as data scientists, and literally 99% of analytics in the whole world is still being done on structured data, right? When you have some variable and it takes values, right? So that's the most important thing. People talk about so many things, so many big stuff as if everything is going crazy, but no, it's a Facebook which can use a lot of pictures. Think about a company, let's say like Canadian Tires. Can it use pictures to do a lot of stuff? Maybe in the inventory management side, but can it use in terms of customers? Maybe, but that application will be very, very little compared to the list of managing tons of stuff when it comes to simply inventory management and supply chain management and so on and so forth. So relational data sets still hold the forte, right? It's not going to go away pretty soon, that's for sure. And so the data frame concept enables you to see it like a tabular data set, and it allows you to think in those lines, right? So that's a beautiful thing for data scientists, right? That doesn't mean that you can't do other stuff, but we will be focusing on this, which will enable us to do a lot of stuff. So now let's look at some of the attributes of Spark ecosystem. So now I have explained what is Spark, loosely speaking, and it has multiple API supports, which we talked: Python, SQL, Scala, Java, R. You can transition from any of these languages if you know, and then you can also integrate it with Spark's SQL, streaming, MLab, GraphX, and data frames, right? We have talked about it. Now, so if you think about a conventional Hadoop setup, every action, every operation is a map and reduce. Map is basically filter, sort, read and write data, and then reduce is nothing but aggregation, summarizing, or coming up with something out of the data processing, right? And then ultimately it is written back. What Spark does is it allows something in the middle, and that something is huge, because you don't necessarily, if you are doing data science application or something, you don't necessarily read data and just write it. Anybody can do that. You process a lot, you create tons of new variables, you do a lot of exploratory data analytics, you see it, then you think about it, and you do next step. It's not automated, otherwise everybody will be doing automated modeling. We don't, right? Very few things can be automated in that sense, right? So Spark allows you to do a lot of middle operations, right? And they can be arbitrary because they don't need to specifically follow a sequence, which Hadoop is very strict about, right? Second, it's an open source platform, so anybody can use it. You can scale it up yourself if you can manage it. It supports Java, Python, Scala, which are very predominant in the market. The beauty about Spark is RDD, the resilient data sets, right? Which essentially means that, you know, they have a fail-safe structure built in, so your processes will not fail. And at the same time, there is redundancy because of the Hadoop stack there, and also Spark has a beautiful thing about it called lazy algorithm. So it will not do something just because you typed a line. No. So for example, if I ask you to go from here to Brampton, it's not that you will just open the door and start running. Then you will ask, okay, how do you want me to go? You want me to take the train or the bus or car or what? You know, then I'll need to tell you, okay, take the train. Okay, then train from where? Go to Union Station and take that. But before I have told you all these steps, how to do that, and if you start to do it, it's idiotic, right? So that's the beauty of lazy evaluation. If you say, Spark learns that, okay, you have asked it to do A, B, C, D, E, but it will only process it when you will say it, when you will ask specifically to do it A, D, and E, then only it will process. So what it does is, had it been a Hadoop structure, right, it will do everything, irrespective, right? But Spark will learn it. That's called an acyclic something, you know. They have tons of nomenclatures here, but it just keeps it in memory. The moment you ask it to return an action, it does it, right? So that's why it is so efficient, and that's why so many companies are doing it, right? It doesn't just run, it runs efficiently, and it has a brain of its own, right? So that's more or less about what is it about and why is it about. And of course, you know, it goes without saying that you will use Spark only when you need parallelization of data. Otherwise, it doesn't make sense, right? You understand what is parallelization of data, right? Everybody or anybody wants me to spend some time over it? Open up. It's discussion. It's a discussion, right?
Yes, it would be nice if you could explain.
Okay. So imagine you have 10 billion records of data, and let's say you have 20,000 rows, 20,000 variables, right? Not just the rows, the columns are huge, right? Just storing that data is going to kill a lot of servers, right? And imagine if you just want to sort it, it will take maybe days, if not weeks, on a powerful machine, right? If you want to speed it up, you need multiple servers, right, working it together so that they can process it fast. But when we say parallelization of data, what we do is, instead of one huge server, let's say I have 100 desktop machines, just like a regular desktop machines, they are all connected together, and there is a master server or master machine which knows what data I am giving to which machine. Its job is to simply know what I have given to whom and what I should get back, what is expected to get back. That's the master, and then others are slave. Right? So it's simply that 1 billion or 10 billion records, let's say it splits into 10 million records, and then 10 million into whatever number of machines, it just gives it. Now, all these machines have got something which they can individually handle. That's very, very good way of doing it. So if I have, let's say, 10,000 pencils here lying on the table, and if you ask me, just sort it by color, let's say 3 different colors, it will take me weeks if I do that, if not whatever, right? But if I ask you, okay, hey, everybody, please come and please help me, everybody will do that, because everybody will know, okay, there are 3 colors and you just need to separate it out. That's the parallelization of data. When you split the job across different packages, across different hardware, but you remember what is being done and by what, by which machine, by which sector, and so on and so forth. That's a completely separate discussion in terms of how Hadoop does it, but that's loosely the concept, right? So that's the parallelization of data, and it only makes sense when you have lots of data. It doesn't make sense if you have very little bit of data, right? So that's the lazy and the RDD concept and the parallelization. Now there are 2 parts which are new in Spark. which are very interesting for data scientists. One is the data frame and second is the data set, right? So data frame, as these gentlemen told us, it's nothing but a tabular format of data. That's it. So software like Python and few others and R, they are all like, they don't do a tons of other stuff like, you know, whether they are doing the code checking even at the compilation stage or not. So they are geared towards handling data frames. Data set is another, it's, you know, it kind of enables real-time checking what you are typing also, you know, right at the compilation stage. So Java and Scala also, I guess, they are geared for that also. So, but for all practical purposes, for data science, we limit ourselves to data frames. Okay, so with the core, we have already talked about, these are some of the content, some of the libraries available with the Spark. One is SQL. No need to talk about SQL. If you don't know about SQL, you shouldn't be possibly talking about Spark for sure. Maybe I'm being offensive a bit, but that's ingredient, you know. If you don't know how to walk, you cannot possibly talk about how to drive a car. You know, that goes without saying, right? Then you have machine learning. For machine learning, you have so many snippets or so many algorithms being written, right? They are being written in R language, they are being written in Python, they are being written in Scala. And every time these algorithms more or less are same, but the way they work are different, right? So mlib library, let's say you are going in Python and you are invoking a library like mlib, then you use that functionality so that you don't have to write your own algorithm. You simply pass on your features or your variables, right, or your parameters, and use the built-in libraries to give you something out, right? So that's what mlib is. Similarly, GraphX is there, and you have many more. You know, it's endless. Now we know about Spark now, more or less we have some idea about it. How does it actually, how difficult it is to actually do it by hands, or how easy it is to do it by hands? When I started my journey in Spark, trust me, I wasted at least 2 months just to make sense of the environment variables of it. It's never stable. It's always doing crazy stuff which we can't understand. Unless you are a IT guy who does it day in, day out, right? It's so tough. Why? Because everything is open source, so there's not a fixed documentation, there's not one way of doing the same thing, there can be tons of ways. So what I will suggest to begin with, you should always go to a pre-made cluster, if loosely speaking. So something which is available, let's say on AWS, it is available. You can just use a pay-as-you-go account on Azure, and you can just hire or rent a Hadoop, a Spark cluster, and you can type in your code. You don't need to worry about whether your path variable is set, whether you have these packages enabled or not, because if you get into that, you can also do it like the Cloudera way. You can have install your CDH and make it work. It never works the way you want. It's always tough. But one of the most beautiful things is, and this is what I think will be very useful for you, is if you can simply go to Databricks. It's a website, most of us will know about it, databricks.com, and there is a community edition for it. Just make a login, just make a username and blah blah blah, use the community edition. You can set up your own machine. For example, here you see this is my, I will just start from the beginning, let it be, otherwise we will run out of time, right? So here I have logged into my community edition. It shows that the default page is there. Now I need to tell, okay, what clusters I need, right? So I just go to the clusters, I create a cluster, let's say I just give it a name, let's say SP34, okay. And Python version 3, Python version 3 and above is the newer version. They are more stable, they support lots of other libraries, so always use Python 3. If you are still on 2.7 or before, please move, because those things are going to be redundant. And then simply create a cluster. It will take its time, but it will do it. So here what you are doing is, virtually, in a virtual environment, you are renting for free here, you are renting a Spark cluster, right, which has an inbuilt Hadoop layer, which has all the memory management, all the efficient packages and everything aligned and prefixed for you. If you have to do it yourself, it's a pain. Maybe Chandan will be able to help you on that. I certainly won't be, because I'm an econometrician, I'm an analytics guy. It's not my job to look into how do I connect these machines, where the cables are going and blah, blah, blah. Certainly not. Chandan excels in that. Maybe he can help. But for me, I'll simply rent it and I will use it. And a lot of organizations, big organizations, for example, they don't do this. They don't create their own clusters and then their their own platforms, because it defeats the purpose, right? If you own everything, it means you have invested a lot of money. It means you have done a lot of capex, right? And that's a problem. The better thing will be if you simply hire or rent the capability from a provider, let's say like Cloudera, let's say Hortonworks or Amazon, and so many small players also, and then just use it when you need, pay it when you are using it, otherwise don't pay, right? So it's the training which is more important. You should have the skills or the capacity to do that. Now we have our Spark cluster running, right? So let's go to our workspace, which is nothing but it will tell me, okay, what I'm going to use. So let me just show you some of the stuff that will make some sense to you. So for example, the easiest thing that you will think about is I have a data set, I want to just make sure that I am able to import it in my Spark environment, right? And then work on it. Challenge is Spark is obviously sitting over Hadoop, and then by design generally these things are in Linux and all that. So now how do you switch your data set from a Windows environment, for example, and then load it to Hadoop environment and Spark environment? That goes into the data processing step, so which I can cover, but given the time I would skip it. Let's say I have already loaded it, saved it, just say copy and pasted it in my Hadoop environment. Now just to read it, because of this concept of data frames, it's so easy now that you can simply write spark.read.format, give it what format the data is, tell it the options. Okay, header, yes, there is an header. Infer schema is equal to true, means just read the fields, and then Spark will automatically assign whether it's a character variable, numerical variable, and so on, date variable, and so on and so forth, and tell where the files is physically located, right? Just do it. Notebook is now running, and that's it. Our internet connection is a bit slow. It should not take that much time, but yes, it's done. It's a small file. Assume it's millions and millions or maybe billions of records. Of course, it will take more time, and it depends on how many clusters you have rented, but it will never fail, right? Now we have read a file. Now we want to see how does it look, because that's human tendency, human nature. Everything is virtual, doesn't make sense for us. We need to have that physical window so that we can see. Very simple commands, nothing fancy about it. That the file that you have read, you have given it a name, sparkdf, and all that you want it to do is to show it. It just shows you the first 20 rows of data, and that's it. It neatly divides it with a boundary. Of course, it doesn't print it like let's say, how will you say, a table structure, but because it is Databricks. Had it been, let's say, an AWS, it will also support a Jupyter notebook. Have anybody has used a Jupyter notebook? It's used for Python. It's an IDE basically, essentially, right? So then you see it in even better format. Of course, you have to pay for it. So that's how you see the data. Let's do something fast. Let's say, okay, what is the count of the rows of the data? Quickly, I can see, okay, 41,188. Can I do some group by? Can I do some data aggregation, which is the key thing that once you have the data? Yes, very simple code. The file, then you ask it to group by on what? 2 variables. After grouping by, what do you want it to club? You want to do the count. Okay, you want to just see the number of rows, and then you want it to show something. That something is education, job, and count, and then you ask it to show, and this is what it does. Very simple, very intuitive, nothing fancy about it, because it's the way you are attacking it, right? Because otherwise, if you pick up a book on Spark or go on a tutorial on Spark, the first thing they will teach you is how RDDs and map and so many things that by the time you have studied it for 2 days, you have already lost your heart in Spark. You don't want to go on any forward. I have suffered. I know it very well. The first thing if I give you is how tough it is, you will never do that. You'll never be motivated enough. You don't want shit around everything, right? You want the things that you need. Not everybody is going to be a programmer. Not everybody is going to land on the moon. No. But yes, everybody can drive a car. So please teach me how to drive a car. That's it. I don't want to fly a plane. That's exactly what my job is here, right? All that I'm telling you is how to drive a car. If you ask me, how can I fly a fighter jet? No. That's not my problem. Okay? So this is how you do it. Let's say SQL. Everybody is very happy about SQL because it kind of, it's like, my good old teenage days, So everybody loves it. So I'm here, what I'm doing, I'm just giving it an instance. I'm giving SQL an instance within Spark, right? So that Spark data frame, the name Spark df, I'm just registering it. That's just a command. Register table as OLS. I'm just giving it a name. So I named it. Fine, I have something, and now I can just run SQL as if I'm doing it in any other platform, SQL Server, within Python, within SAS, within R, wherever, within SPSS, whatever. What changes? Nothing. You only need to write spark.sql before the code, and then everything is SQL. Select star from blah, 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 and then you ask it to show it, right? If you ask it to show it, it shows you. If you don't ask it to show it, let me run it. I don't know if I ran it or not. Yes, I ran it. And now you can also write it into another data frame. You want to do something, you want to write it back to a file, right, which you can use. You just assign it a name. I just gave it a name T. That's it. I didn't ask it to show it, right? It's done. What else? Let's say I have read a file and I want to see what each of these variables are. What are their names? What are their characteristics? How many are float, how many are integer, how many are character, and so on and so forth. Here it is. It is called schema, right? This is what the schema is. You can change it, of course, if you want. But let's say we just go ahead with this. Okay, this is the schema. These are all my variables. Now let's do something beautiful. If whosoever has done any bit of work in Python, they will know what pandas is. Anybody who has worked in Python before? 3 people? 4, 5? Raise your hands. Why are you shy of me? Right? So 1, 2, 3, 4, 5 or 6. Okay. So in Python, just like Spark, it's also an open source this thing, right? And a lot of packages or libraries have been created in C language, right? One of them is pandas, right? Pandas has been designed to enable Python, for example, to work with data frames or tabular data, right? What you are doing is you are essentially going to Python from Spark, okay? So as if you are doing everything in Python, using Spider or Jupyter or whatever, right? So you are simply invoking, just like you would do in Python, import pandas, you gave it a name as PD, and now everything you are doing is as if you are doing Python. So you simply do, okay, data frame, do it, and give me a transpose, just let me see the data. This is what you did, okay? Now, blah, 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 let me quickly jump. I don't want to run out of time, otherwise Hiren will kill me, okay? So this is what I just create. I'm just doing some stuff. I'm just creating a list of numerical features from my data, and I'm just printing it just to check it, what it looks like. I'm just again importing it, even though it is not necessary, and I'm just trying to create, okay, a different thing, scatter plot and something, which I will show it here. Now let me do some correlation plots. Simple. Some of these are like declarations. You want it in a color on blah, blah, blah. I've done some customization. You can do on your own. It's pretty simple, makes a lot of sense. Here, matplotlib is a library available in Python for creating graphs, 2-dimensional graphs, and charts and bar charts and horizontal diagrams and whatnot, right? You have simply imported that in Spark, and then for every variable, what all numerical variables you have just created beautiful correlation plots. So that's your exploratory analysis that you do if you are a data scientist, right? You don't make machine learning models out of air, right? You use the data, you do a lot of analysis before you actually do something. And then you clean the data, you create new features. That's what we call as feature engineering. Once you have done your feature engineering, exhaustive feature engineering, then you do feature selection, which is again a tough job and a good job, and one of the most important jobs for data science. Once you have done your feature engineering as well as feature selection, this is a part of feature selection as well as feature engineering, I would say. And then once you have done it all, you have selected, then you have defined everything, then you design a pipeline, what we call, okay, we will do step A, B, C, D. And once you do that, then only you go to machine learning, right? Not before that. Otherwise, it's crap. Okay? So now I will just jump. Now here I am, pretty, it will look like very tech stuff, but I'm doing simple things. I'm doing one hot encoding, which is a known thing in data science. If you will take some of our other classes, like I teach data science, machine learning models using Python. So it will make far more sense if you haven't done it before. So there we do hot encoding. Basically, let's say there is a category called jobs, and there are 15 different classes, right? So job can be student, can be a teacher, can be a doctor, can be an engineer, blah, blah, blah. So we create dummy variables for each of them so that we can manage it. That's hot encoding. Then you have, you do a lot of indexing so that you can keep the categorical variables separate and the numerical variables separate. And you do a lot of stages, you assign it separate stages, and you create a pipeline. That's what I'm doing. And once it is done, let's say now my pipeline is ready and I am going to create a logistic regression. Anybody knows what is the logistic regression? Anybody? You know it, right? So basically logistic regression is nothing but estimating the probability of something, probability of event, right? Which is different from probability, from estimating, let's say, a continuous variable. Let's say you want to predict, okay, given this much of my income, how much people will spend, right? Income and consumption, right? There are variables which can take any value. Somebody might have zero income, but their income can be in millions, right? But your consumption, it might be even zero, or it can also go to any value, right? But the problem happens when it is a probability. Probability is that whether you will default or not. So either you will default or you will not. There will be nothing in the middle, right? So either you are 1 or you are 0. So that a probabilistic or a dichotomous statement, as we say in econometrics, to handle that, you need a separate framework, which is, let's say, a logistic regression. Most of the machine learning applications are for dichotomous variables, right? Which take class options, right? 0, 1 or 0, 1, 2, 3, 4. You will go from here to there by using bus, TTC, go train, car, taxi, or whatever. These are options. So that doesn't mean that a taxi is greater than TTC or whatever, right? You are not allowing it to, 5 minus 4 is equal to 1. No. All that it means, 5 is car, 4 is taxi, or 4 is train, or whatever, right? Now our pipeline is ready. It will take time. Should run. Oh, I need to run C. I need to define it here. I didn't run that. And then we will jump. I'm jumping a few things, selected columns. Okay, I'll just go straight away, because otherwise to debug I'll take more time. See, debugging. Now let's say I'm doing all this. Okay, I'm deciding my pipeline, I've designed my pipeline, I've given it some of the coefficients. Okay, what is my training data set, what is my test data set, I have just split it 70-30. Normally if you have, let's say, 100,000 records of data, you want to make a model, you will do 70% data you will use for designing the model, and 30% of the data you will use for testing the model, whether you have done a good job or not, because just because you said it doesn't make sense, right? Then you run a logistic regression model. Here, for example, what I'm doing, I'm telling it that my feature columns are in the list features. My label is already given what these features are. What is my maximum number of iterations? For example, I've given it for 10 times, and then I'm fitting a model, right? After I do that and I ran everything, then I get a nice little ROC curve. Anybody knows what is an ROC curve and what is the usage in machine learning? Nobody? Okay. So what I mean is, when we design a model, it's not just we just code and go home. Anybody can do that. You can just copy paste, right? What is the difference between you and me? Let's say if I'm doing, and let's say you are a student, you are doing it. I have brought with me 15 years of experience. I know where it goes to shit. Right? So I will not make a model which looks beautiful but doesn't work. I will make a model which may not look very beautiful, but it will always work. Right? That's when this is the concept of called ROC curve, receiver operating curve. Right? What we do is we look at the false positive ratio and the false negative ratio, both the sides. So what I mean is, if let's say I made a model, but what that model is doing, it is telling that these 10,000 people are going to default. But actually, out of those 10,000 people, only 1,000 defaulted. So 90% of the time, I am telling wrong people will default, right? That's my false positive. So had it been a credit card, let's say swiping, you are swiping and I have made a model, such crappy model, what will happen? Every time it will say, oh, this is going to be a fraud, it will block it. Once, twice, thrice you will leave, fourth time you will say, I am going to TD. This is going to happen, right? That's a cost of false positive, when you are causing inconvenience to customers. On the other hand, there is a false negative that, hey, somebody did fraud on my card and you didn't even stop it because you thought it's not a fraud, right? So whenever you flagged, 90% of the time you are wrong. Or whenever the actual fraudsters, they were actually successfully able to commit the crime. They were able to transact. That's your false negative. You're wrongly saying something is going to default when it is not. So you want a model which is somewhere in the middle, where it's not flagging too many wrong incidences, but it is also not allowing too many actual frauds to go through, to filter out. That's the job of data scientist. Till now, whatever we have talked, even a data engineer could have done. But now you are going into a domain where it is data scientist, right? Then you also look, a lot of other things, precision and recall, which is again, mathematical jargons. But essentially, what you are trying to do is how often are you able to capture a fraud correctly, and how often you are actually saying that a good customer is actually good. That's kind of a precision and recall balance. Again, there will never be a model which is 100% on both the sides. You will always have to choose in the middle. That's when you need the training, you need the advice, and you need to hire somebody like me, right? So the next thing is, all these tools. And if somebody told you that they can make you a data scientist in half a day or in half an hour, they are shitting you. No way. Okay? You need to spend your time, because that's the only thing that you can do, and that's in your hands. But yes, spend the time correctly in the right direction. For that direction, we are there. Okay? Thank you.